Hello, Algebra 2 students. We're going to start 2.7 parent functions and transformations, and we should get it all done in this video. So we can identify and use parent functions and then describe the transformation of these functions. So here are the 4 parent functions you need to know. So at this time, go ahead and take a moment to pause the video and write these down in your notebook. All right, so we have a constant function where y just equals a value, any number. The domain is all real numbers. The range consists of a single number, a, and that's a straight line, no slope at all. Then we have the identity function, which is f of x equals x. And it passes through all points and coordinates where we have a comma a, and it is the parent function of most linear functions. So we have the linear function, also known as the identity function. Domain and range is all real numbers. We learned this in the last section, absolute value function, where the domain of f of x is the absolute value of x, or excuse me, where the domain of f of x equals x is a set of all real numbers. And the range then is all real numbers greater than or equal to 0. So f of x is greater than 0. And then we have the quadratic function, which is our parabola. So anytime you see this U shape, you know it's going to be something with x squared. And it is the set of real numbers, and the range is the set of, or excuse me, the domain is the set of real numbers, and the range is the set of real numbers greater than or equal to 0. So these are the 4 that we're going to concentrate on. And then, so now we're going to talk about how we can transform them. So we can translate, a translation moves the figure up or down or left or right. So if you notice here, when we add or subtract a value outside of the function, we're going to, that shifts it up or down. So in this example, see how we're adding 2? So then our vertex is shifted up 2. And then when our value, when we add or subtract a value inside the function, so like here is inside the absolute value bars, we shift it left or right. And this one you always have to remember is opposite of what you think, opposite the sign. And it has to do with the vertex form, which I can get more into class. But it has to do with setting it equal to 0. And so here we had x plus 3. So if we're going to add 3, then that shifts the graph to the left 3 units. So it's the opposite of what you think. A lot of people think, oh, I'm adding 3, I should shift it to the right. No, no, no. You're going to add 3 inside, you got to shift it to the left 3 units. So that's a translation, moving it up or down. A reflection flips a figure over a line called the line of reflection. And I think I wrote that twice, sorry about that. And so if we have a negative on the outside of our function, then it is a reflection about the x-axis. And then if we have a negative inside the function, as you notice here, then it's about the y-axis. So notice here we have the quadratic function, and we have a negative on the outside of the x squared, so therefore it's going to, outside, so it's going to flip about the x-axis. It's going to flip it upside down, make all those values negative. Now dilation shrinks or enlarges the figure proportionally. So if it's multiplied by a coefficient greater than 1, then it is going to be stretched vertically. So it's going to be stretched up and down the y-axis. If it is multiplied by a coefficient between 0 and 1, so that would be a fraction, then it is going to be compressed vertically. So it's going to get fatter. That's how I remember it, compressed vertically. So stretched or compressed. Stretched means it's going to rise at a faster rate. compressed means it's going to go slower. And think about when you're timesing by a fraction, essentially you're dividing by a number as well. So it's going to rise slower. So let's look at this function right here. And let's just name the parent function, then describe the transformations of this graph. So we know we have a squared right here. And so that is going to be, it's a quadratic. Okay. Now we're going to describe the transformations. So what's the work left to right? So this 4 right here, it's greater than 1. It's a coefficient greater than 1. And because we're multiplying the quadratic by that. So since it's greater than 1, it's going to be stretched vertically. So it's going to rise at a fast rate. Now we have plus 2.5. Remember, it's the opposite of what you think it's going to be. And so since it's on the inside of our function, inside the parentheses, it's going to move to the left 2.5 units. And then we are subtracting 25. And on the outside of the function, we're going to subtracting. So subtracting is just how we think it is. Our graph is going to go down 25 units. 25 and 2.5, that's kind of confusing. I better make sure I have that point in there. There we go. And so that's how we describe the transformation. And on this next slide is kind of how we, just summing up everything that we've done. Feel free to write this down if you want to. It might clear up a few things, but come with some questions if you may have any. And I'll see you guys later. Adios.